Okay, let's start our activity 2.7. The first, we are going to solve these two questions by the two methods, ISBN 13. First question we are going to solve by only one ISBN 13 method, and the second question we are going to solve is going by Modulo 11 and ISBN 13 method. Why I'm calling it 13, you will understand it when we are going to solve it. Okay, let's see this question. Here we have solved this with ISBN 13. We have to calculate the check digit for this number, and the method we are using is ISBN 13. So what we have done, we have separated all the boxes for each digit, and we have written those numbers, and we have multiplied the numbers in the odd position with 1 and numbers in the even position with 3. So this 9 is the first position, so first 1 is odd number, so this is multiplied by 1. This 8, it's in the third position, 3 is odd number, so 8 is multiplied by 1. Again, this fifth position, uh, 5 is odd as well, it is multiplied by 1. This is seventh position, 0, and it will be multiplied by 1. This is ninth position, 5, it will be multiplied by 1. This is 11th position, 5, and it will be multiplied by 1. And then we have even positions, they will be multiplied by 3. 7 multiplied by 3, 1 multiplied by 3, because it is at even position, because this is second position, this is fourth position, this is sixth position, 8th position, 10th position, and 12th position. What we are going to do, we have multiplied by them, and here we've got the result row, and in the result row we add all these values and we got our sum as 119. When we divide any number by 10, the next step is to divide that by 10. The last digit of that number is the remainder. So we divided 119 by 10, so the 9 is the remainder, and we subtract 9 from 10 and we get our check digit, that is 1. 10 minus 9 gives us 1, so this is our check digit, that is 1, and this is our final number, 9781510455759, and 1 is the check digit for it. Let's go for the next question. For the second question, we have to find the check digits for the following by using both ISBN 13 and Modulo 11. Why I'm calling it 13? Because we are multiplying by 1. The first, third, fifth, all the odd positions, we are multiplying even positions by 3. This is why we are calling it 13. Okay, this is our first question, 213, this number, and we have to generate its check digit. Let's start it. What we have do, the same first step, we have made the separate boxes for all the digits, and we multiplied all odd positions by 1 and even positions by 3. And when we multiplied it, then we got the result row, and in the result row we have added all those values together. We got our final sum, that is 53. The next step is to divide that by 10. We divide it by 10. Obviously 3 is the last digit, so the remainder is 3, and 3 is our final check digit. And so 3 is, this is the check digit, and this is our final number. Now, what we do in the Modulo 11, we have already studied it. Let's repeat that again. We assign the weights to each digit. Here we have, basically, this is a 12-digit number. We have started the weights from the number 13. We have used one additional number. So for 2, we have assigned the weight as 13. 1, we have assigned the 8 as 12, and 3, and all each digit we have consequently as lowering the weights of all the next digits. So the final digit, final weight is 2, and so once we assign the weights, we multiply all the weights by their positions of those digits, and we got these multiplied results. And once the multiplied results are calculated, we add all those multiplication results, we get our final number as 136. Now in this case, in Modulo 11 case, rather than dividing by 10, we divide it by 11 and get our remainder, and we subtract that remainder from 11. 136 divided by 11, the remainder we have got is 4. And when we subtract 4 from 11, we get our number as 7. So 7 is our ultimate check digit. And so the final number has all these digits and 7 at the end as the check digit. It is written in bold so anyone can understand that. Now this is now the second part, 909, this is what we are going to solve now. See, it's the same method, we have just changed the digits. You can see this is by using ISBN-13 method. We multiplied the odd positions by 1, even positions by 3, odd position by 1, even position by 3, and all those positions are multiplied and we got our result row. Once we got our result row, what we have added all those values. Once we have added all those values, we got the sum as 90. Once we divide the sum 90 by 10, we get our remainder is the last digit is 0. So 0 is our final check digit and the final number is this. Now let's do it by using modulo 11. We get a different check digit. So obviously there are 12, it is a 12 digit number, so we got the highest weight as 13. Then we are decreasing it with the next digits, and once we have decreased, and then we multiply each digit with its weight, and then we added all the multiplications of the digit and the weight, and once we have added them, there it is, the sum is 395. If we divide the sum 395 by 11, remainder we got is 10. So 11 minus 10 gives us 1. 1 is the check digit, so the final number is this, and 1 is our final check digit. Okay, let's move to our next topic, and let me open that slide for you, and let's see how we go about that. Okay, it's taking a while. Let me do this for you. This is our next lecture. We are done with the check digit and those mathematical part. Let's move to a theory side of that data transmission. There's another concept called automatic repeat requests. ARQ, we also call that ARQs. And let's start it. Data transmission may contain errors or security risks. Systems are needed to detect errors, ensure correct delivery, protect data from unauthorized access. Main content. ARQ method, it is a method that is used to ensure that data is received correctly. It uses different error detection methods like check digit and CRC, and there are numerous others. How ARQ works. Receiver checks data for errors, and if no errors, it sends an acknowledgement. ACK means positive acknowledgement. And if errors, then it sends a negative acknowledgement that data is not received correctly. It contains an error. Then sender resends if there is a NAC message. Then there is another role of timeout. Sender waits for the acknowledgement. If no response within the time limit, data is resent. Process continues until ACK received and maximum retries reached. Okay, we retry this acknowledgement and an ACK-NAC method if the data is not received correctly. For any negative acknowledgement, we keep retrying it. We set some limit for the retries. So obviously, this process continues until we do some maximum limit of retries. Uses of ARQ. ARQ ensures data integrity, means data is our correct data. It means that the data that is at the sender's end, the same data should be at the receiver's end. This is what it means, integrity. Commonly used in mobile phone networks. Purpose of encryption. There is another concept called encryption. It has a purpose. What it does, it protects data from hackers, makes unreadable data if intercepted. Then hackers are not able to understand it. Important for sensitive data like bank details, medical records. And then there is a plain text and ciphertext. Plain text is equal to original readable data, and ciphertext is encrypted data that is called ciphertext. Encryption converts plain text into ciphertext. Then there is another thing called decryption that converts ciphertext into a plain text. This is our encryption and decryption are used whenever we have to send the data from one place to another. Then there are different types of encryption. First is symmetric encryption. Symmetric encryption uses one key for both encryption and decryption. Basically, we have the concept of keys. Suppose this is our data, plain text data. Then we have a key that generates a cipher text. This is, you can call it a key, and with key we generate a ciphertext. Ciphertext is our encrypted data. I'm just writing it as E, and then encrypted data is sent. Once encrypted data is sent, then the receiver decrypts it with the same key that encrypted data has. Then the decryption processes occur this same with same key. Key is used to decrypt the encrypted data. Once it decrypted, then the ciphertext converts to which text is decrypted. Ciphertext is decrypted, and then it converts into plain text. I should have written here as plain. So this is a process. The book has the better diagram. Let's, but this is also enough for the understanding for the lecture. You must see the book diagram as well. Advantages of symmetric encryption. In symmetric encryption, we have the same key. This key and the encryption and decryption, both keys are the same in symmetric encryption. What is the benefit of it? The same key is with the sender and the receiver, and it has a faster access and simple to implement rather than and then there is asymmetric encryption. That is another kind of encryption. Disadvantages of symmetric encryption is key must be shared securely. Risk of the key being intercepted. There is a risk that is between the sender and the receiver. If someone gets a key for the from the sender, then he has the ability to decrypt it at the receiver end as well. Security depends on secrecy of key. Obviously, security depends on the how secret is the key. If the key is leaked, then there is no security. Let's see the asymmetric encryption. That is much secure. It has two keys, one key for encryption and the other key for decryption. Public key is for encryption, and there is a private key that is used for the decryption, that is only at the receiver's end. So both there are two different keys are generated and they are shared with each other. So sender does not need to know the decryption, the private key. So that is the benefit of it. How it works, how asymmetric encryption works: receiver generates public and private key pair. Receiver generates the key pair. Okay, and public key is shared with the sender. Sender has only the public key. Sender encrypts data using public key. Receiver decrypts data with the private key. So there are two different keys. If public key is leaked, then then he won't be, no hacker will be able to decrypt or read the message. He will require a private key, and he can't acquire the private key easily. So this is why it is much more secure, but it is a little tricky to implement. Okay, and but the most important thing is no one should share the private key. And this is the process is explained in the practical manner. Sender sends data, receiver checks for errors, sends acknowledgement if correct, sends negative acknowledgement if incorrect, sender resends data if needed. And then there is a symmetric encryption. Suppose there is a key for 291, letters shifted based on the key, same key used to decrypt message. Then asymmetric encryption. Suppose Jane creates a public and private key, sends public key to Tom. Tom encrypts message using public key, Jane decrypts using private key. At the moment, Jane can only receive encrypted documents from Tom. Describe what would need to happen for Jane to be able to send encrypted documents back to Tom. Okay, what should happen? At the moment, Jane can only receive encrypted documents from Tom. Describe what would need to happen for Jane to be able to send encrypted documents. Jane should have the private key. Tom must generate his own public and private keys. Tom sends his public key to Jane. Jane uses Tom's public key to encrypt message, and Tom uses his private key to decrypt the message. At the moment, okay, this is a question. At the moment, Jane can only receive encrypted documents from Tom. Describe what would need to happen for Jane to be able to send encrypted documents. How can Jane send encrypted documents to the Tom? So for Jane to send encrypted, Tom must generate the keys. obviously. As previously, Jane is generating keys, so for Jane to send the data, then Tom must generate the keys and shares the public key with the Jane. Explain why symmetric method is much more secure than symmetric. The private key is never shared. That's the most important. Only the intended receiver can decrypt the message. Okay. And even if the public key is known, it cannot be used to find the private key. It removes the risk of sharing a single key. That's the benefit of asymmetric. Whereas in symmetric, there is only one key for both sender and the receiver. Now there is a multi-user communication public key sharing. One user can share her public key with many users. Multiple users can send encrypted messages to Jane. All messages are encrypted using Jane's public key. Jane decrypts all messages using private key. For two-way communication, each user must generate their own public and private key. All users, okay, so for two-way communication, each receiver must generate the public and private key and send their public key to the sender. All users exchange public keys with each other. Messages are encrypted using receiver's public key, and whereas each user decrypts using their own private key. As number of users increase, complexity increases, more key exchanges are required, obviously. Let's see what, let's see, do some MCQs. What is the final number in a code used to detect entry errors? Okay, to detect entry errors, what is the final number in a code? That is check digit. And next is which method uses acknowledgements and timeouts? Answer is automated repeat requests that is used for the acknowledgements and timeouts. Which method adds an extra bit to ensure even or odd number of ones? That is simple, it's a parity check. Which method sends calculated value after a block of data for comparison? Obviously, that is using the checksum. We calculate a value and send it with the block of data. Okay, which method sends back a copy of the data to check correctness? Obviously, echo check. That's it for this class, and we'll go continue with our last topic in the next lecture. Thank you.